In this video, we're going to derive the derivative for arctangent of x by following some steps. And first thing we're going to do is we're going to rewrite this in terms of tangent. So what that means is if r of x equals arctangent of x, that means the tangent of r of x equals x, because that's what it means to be an inverse. Now what we're going to do is differentiate both sides of this with respect to x. So over here I've got a chain rule, and so I'm going to do the derivative of the outside function, which is secant squared. I'm going to leave the inside alone, r of x, times the derivative of the inside, which is r prime of x. Now on the other side I have x. We're taking the derivative of x with respect to x, which is just 1. And then we can say, okay, well then, let's solve this for r prime, because that's our ultimate goal. R prime of x equals 1 over secant squared of r of x. Now we're going to, we're going to do a little bit of work here to simplify this. First off, remember that r of x is actually arctan of x. So what we're going to do is do a couple of rewrites. First off, 1 over secant squared is cosine squared, so this can be rewritten as cosine squared, and now r of x, remember from our original, was arctan of x. And so there we have this thing in terms of cosine and arctan. Now what we can do is we can actually simplify this thing a little bit more, and what we're going to do is we are actually going to let theta, how do I want to write? Theta is going to equal arctan of x, and that gives us that r prime of x equals cosine squared of theta. Okay, now we do this to simplify the formula. That means we know that if we put in our triangle here, a right triangle, and call, say, this angle theta, would be this one or this one, doesn't matter. And rewriting this, remember this, if arctan of x equals theta, that means tangent of theta equals x. And I'm going to rewrite this as x over 1. Remember, the tangent relates the opposite side and the adjacent side of a right triangle. So this side would be x, this side would be 1. And thus, by the Pythagorean theorem, this side would be the square root of x squared plus 1. So those are our three sides of the right triangle. Now what that tells us is that we can actually do a little bit more rewriting, because we now know that cosine of theta is the adjacent over the hypotenuse is 1 over the square root of x squared plus 1. Now that wasn't our final answer. Remember, we wanted r prime of x, which is cosine squared of theta, but we're only one step from that because it's going to involve squaring both sides here. We'll square this side and we'll square this side, and what we end up getting is the derivative for arctan of x. So r prime of x is going to be this squared, which just gets rid of the radical, 1 over x squared plus 1. And there we've derived the derivative for arctan of x.